functions. But if I change a variable into the function, it's not changed back to the main R level. If I want that a change in II that is assigned into the function is recorded in the main R level, I have to use this instruction assign, which means that the variable II, if it is modified into the function, it's also modified into R. And let me just check, because I don't remember well, the help of assign, I don't remember, yeah, position, perfect. Okay, let me try in this way. And first, let me check if I source the program, if it works. Okay, and let me just try to run it. Yeah, it seems that it works. So I go back to the program now, and at this stage I can go down to here, and I can write II is equal to II plus 1, and then I can write if II equal 20, and then I need a curly bracket. Here I put II equals 0 and the curly bracket. Basically, I increment any time that the function is called, I increment the II value, and then I tell the program to make the plot and to print on the screen the sum of squares only when II is equal to 20, so after 20 iterations. And then once that it's printed out, I reset the value of II. These operations on this variable I that I'm doing inside the function wouldn't have any effect on the value of I into R, into the main R console. And therefore, unless I assign it, as I did, and therefore, if I didn't assign it, II would be always equal to 0, and I would never get a printout. But let's make a check, okay? Let's make checks to see whether it works in this way. So, the program is now saved, and if you allow me, I go back to R, and I source the program, and let's run the minimization, the optimization. Okay, let's see what happens. Okay, so position equals 0. Okay, just a second. Let me check. I think assign let me see. I think that I need to say that II is equal to the variable II in R. Let me see if it works in this way, okay? Position is not 0, but is something like let me check what are the options for position, because let me see details. Let me try to use the default. I try to use the default. Let me check if it works. Doesn't work. Sorry for that, because I was not planning to use this and I didn't refresh my mind. I'm pretty sure that it should work in this way with the correct value of position. Okay, let me try with position equal 1. Sorry if I'm moving forward with trial and error, but I think it is the quicker way to go. And when I find the solution, I make a summary. Let me see. Let me do it this way. Let's see if it works. After 20 iterations, we should get the graph and the sum of squares. We need to wait a little bit. It's a bit long. I think it's already too much. I think it is working but not printing out, so there is this possibility. Let me check here. I think that now should be so. I'm now putting a printing instruction for II to check if the value is incremented at each time step. So let me see. 0, 0, it's never incremented, you see. So let me do like this. Another attempt. Doesn't work. Just 1 second. I think it is correct with the only thing that the position command, it's 0 shouldn't be correct. No. Just give me 1 second, I check it. Okay, this is the instruction. I guess that now is working, but let me make a check. Okay, so okay, let's suspend this, okay? The only problem here is the specification of the environment. It's not II, it's not updated. Anyway, this is just a technical issue, naming that the question is how to update a variable into a function and at the same time updating it into the main R environment. And I inspect it and I'll get back to you. The question of model optimization is nevertheless solved, because if we forget about this and remove this assignment and we go back here, remove this if cycle that was just meant to print the results once in a while and not anytime, and if I comment at least the plot, which is the thing that slows the program down, and I run the optimization is going to converge. So if I source the program in this, with the only problem that we are getting the sum of squares each time, and this slows the program a little bit down. Still, even if we remove the printout on the screen, we will still get a procedural routine that is extremely slow, and therefore it may be required that you shorten the length of the calibration period, because 8,000 data, it's a bit too long. Therefore, this is a possibility that you have two possibilities at this stage. Either you leave the computer running during the night and you get the result at the end, or you reduce the length from 8,000 to 2,000, and then it becomes faster and faster. There is sometimes a potential problem that while trying several trial parameter values, the IMOD code could give back a value that is like minus infinity or plus infinity, and this could cause an error in the program, because when it computes the sum of square is if there is a value of the river flow that is plus infinity, then the procedure stops. So it may also happen that the program runs for 4 hours and then you get an error. This is a possibility that must be checked, of course. And if this happens, there are two options. Either to try to identify what caused the mistake, and if it was a value of plus infinity, you could make a control in the code that whenever you get a value that is plus infinity, you substitute it with a value of 0, for instance. Or a value that is not plus infinity, but it's 1 million. So you put an upper limit to the output of R. Or you change the lower and upper limit for the parameters. If you change them, then you probably solve the problem. I'm not sure you get it. Maybe that you don't get any problem. But in any case, you may try. You leave the computer running overnight, and in a couple of hours, I think it will converge. Okay, now to conclude, I just would like to show you the code in its final form, which is here. And I removed any assignment, and meanwhile you can inspect how to play with the function assign. And if you don't play with it, the next time that we will have exercises, I tell you. And then the code is basically what we did up to 15 minutes ago when I started working with the sign. If you don't have any question, that's it. Okay.